So now we'll study about van der Waals forces. শোনো, এখন হলো এই চ্যাপ্টারের সেকেন্ড পার্ট। ফার্স্ট পার্ট শেষ করলাম, now is the second part. So van der Waals forces, so imagine this is a fluorine and a fluorine. Okay, so Tanaz, Shanil, how many electrons does a fluorine atom have?
So total electrons in outer shell?
Total. 9. Okay. This is 9, this is 9. So এই মলিকিউলটার মধ্যে তোমার কয়টা আছে? 18, right? 18. 9 electrons from one fluorine atom, 9 electrons from one fluorine atom. The total molecule has 18 electrons. আমরা আরেকটা ফ্লোরিন নিলাম। So how much does this molecule have? How many? 18. Okay. So we are taking this as a molecule, F2 molecule. This is also F2. So listen. So this F2 has 18 electrons. So if আমরা যদি এটাকে হাফ করি, আমরা এটাকে যদি একটা ইমাজিনারি লাইন দিয়ে এটাকে যদি হাফ করি, তার মানে on this side it has 9 electrons, on this side it has 9 electrons. Okay, so we know that electrons are like, electrons are like the planets in an orbit. কি হয়, যেমন the earth is rotating around the sun, or the planets are rotating around the sun. Electrons are also rotating or going round and round and round. হঠাৎ করে, on some instant or under some circumstances, it is seen that out of 18 electrons, there are 14 electrons on one side and 4 electrons on this other side. Or initially they were 9 and 9. The electrons were rotating. The electrons were rotating like this. They're rotating. হঠাৎ করে, on some instant, you see that there are more electrons on one side of the molecule compared to the other. So what has happened? They were supposed to have 9 electrons, but now it has 14 electrons. So আগের থেকে এটা কি হলো? There are more or less electrons. Tanisha?
More electrons on one side.
They have more electrons on this side.
Sir?
Yes?
Sir, একটা কি বেশি ইলেকট্রোনেগেটিভ হয়ে গেছে?
একটা বেশি ইলেকট্রোনেগেটিভ হয়ে যায় না, বাট একটাতে now since there are more, or থাকার কথা নয়টা, it is supposed to have 9, but now it has 14. So now it has more than expected. So now it has now become a partially negative. This side has become partially negative and this side has become partially positive. Why? Because it was supposed to have 9, but it has 4.
So কেন 4 আছে এখন?
So তোমাদের ছোটবেলায়, আমি জানি না whether you have played it or not. So this is a table and children goes like round and round and round. They go round and round. So হঠাৎ করে দেখবা যে due to different speed, there are more kids on one side than the other side. Right? Normally they were supposed to be equally distributed. But now, due to different motion, there are more kids on one side. এখানেও same thing. They were supposed to be equally distributed, but while rotating or revolving, you have more electrons on one side compared to the other. সেজন্য এখানে একটা temporary force হয়, which is a partially negative charge and a partially positive charge. On the other hand, this side had what? This side had 9, this side also had 9, right? This is our second molecule. This is our first molecule. So second molecule also was equally distributed. But what is happening? Since this side has become partially negative, it will repel the electrons away. It is gonna repel the electrons away. The negative charge will repel the electrons away. So ki hobe? If it repels the electrons, suppose this becomes 2, this becomes 16. So this becomes a partially positive side, this becomes a partially negative side. Let's take another one.
Repel cannot করবে?
Like charges,
Oh, like charges repel.
like charges repel. So this is our third molecule. So the first molecule, left hand side, what happens? What happened? It's partially positive, but this fluorine molecule is again 9 here, 9 here. They're equally balanced. So what the partially positive charge would do is it will attract electrons towards itself. Ekhane it's repelling, here it's repelling, here it is attracting. So as a result ki hobe? As a result, now they have more electrons on one side compared to the other. So this becomes again partially negative, this becomes partially positive. Isn't it like a chain reaction? Isn't this like a chain reaction?
Yes, sir.
So this will keep on going on. So ekhane ki holo? It is a temporary force. That's why this force, the attraction which finally arises, is van der Waals forces.
Sir.
So why is it, yes, just a moment. Why is it van der Waals or temporary? Karon, hoytoba now it is 4 on this side, 14 on the other side. What if in the next instant or in the next moment it becomes 10 on this side and 8 on this side? This can happen. It is constantly changing. Tale ki constantly changing jodi hoy, will the forces be strong or weak?
Weak.
The strong forces will be weak, and this is nothing permanent. This is constantly changing, and when these change, its surrounding forces will also be changing. So that is why this is known as van der Waals forces or dispersion. Dispersion মানে কি? They are in এটা একটা induced current আছে না, we induce current. It's like an induction. We induce a force. So that's why this is also known as induced dipole forces. Induced. Why is it called induced? Because this fluorine molecule is inducing a force on this fluorine molecule. This fluorine molecule is inducing a force on this fluorine molecule. Am I clear?
Sir.
Yes, sir. Sir,
Question.
question আছে একটা.
Yes.
How do the electrons মানে এমন হয়, মানে how do the electrons shift to one side?
So electrons are arranged in different layers, right? So electrons are moving. It's moving. So it due to so আমরা তো there are so many forces acting. তোমরা কি centripetal আর centrifugal forces পড়েছো?
Yes.
Sir.
So centripetal force centrifugal force is basically based on the center, they're moving, right? So there are so many factors affecting. So Jamon, electrons in the last shell would be easier to move around. Keno? Because its attraction to the nucleus is less. On the other hand, first shell electrons are going to move less. Why? Because it's closest to the nucleus. So for some reason, for some reason, while rotating around the nucleus, instantly or for a very small fraction of a second, there are more forces, or sorry, there are more electrons on one side and less electrons on the other side. And due to this, they're inducing a force on their neighboring molecule. That's why this is known as induced dipole-dipole or instantaneous dipole-dipole. Instantaneous maniki, instantaneous speed or instantaneous velocity. Have you heard about this?
Yes.
Yes, sir.
What is instantaneous? Fraction of a second for a very small time. This is also the same thing. Van der Waals forces are very weak, and as a result, since they're very weak, they do not give rise to very strong forces. The Van der Waals forces are strong or weak intermolecular forces?
Weak.
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 Weak intermolecular forces. Acha. Tapor I taught you what are the factors affecting Van der Waals forces. Bolo to? Factors affecting Van der Waals forces.
Nuclear charge, electrons in outer shell are arekta jay na.
Number of electrons. Number of
Charge.
electrons in a molecule. It is at number. And number 2 is?
Charge.
Nuclear charge.
Number 1 is?
Charge.
Number 1 is number of electrons in the molecule. And number 2 holo number of contact points. Rama. So A duto holo.
Sir,
Yeah.
like the question, Shilu, like what if again, like the electron distribution becomes like equal on both sides again?
There won't be no forces. But it actually hoy na. There's always the difference in electron distribution.
So, sir,
Yeah.
it can happen with more than 3 fluorine atoms as well. Millions.
Millions of fluorine atoms. Yes.
Oh.
Millions of fluorine atoms. So ধরো যে একটা যদি neutral হয়েও যায়, his neighboring molecules will not let him stay neutral. Oh, it's rotating, right? So it's going to induce a force. So Van der Waals forces holo number of electrons and number of contact points. So it will continue next class. But before that, I'll ask you please go through some videos on intermolecular forces. It's like hybridization. Eta tumi 2D te bujhano, it's difficult. If you actually watch videos, it's going to be much more easier for you to understand.
In this video, you're going to learn what we mean by intermolecular forces, that there are 3 common types of intermolecular force, and the difference between these 3 types of intermolecular force. An intermolecular force is simply an attractive force between neighboring molecules. There are 3 common types of intermolecular force, namely 1. Permanent dipole-dipole forces, 2. Hydrogen bonds, and 3. Van der Waals forces. All of these 3 forces are very much weaker than ionic or covalent bonds, which bind atoms and ions together in elements and compounds. We have a video each on ionic and covalent bonds if you haven't learned about them yet. Let us now look at these three intermolecular forces one by one. First up are permanent dipole-dipole forces. A polar molecule is one in which there is a permanent dipole, arising usually because the different atoms in the molecule have different electronegativities, the attraction by a bonded atom for the pair of electrons in a covalent bond. Let us take hydrogen chloride as an example. Hydrogen chloride is a polar molecule, as the pair of electrons in the hydrogen-chlorine bond are nearer to the chlorine atom. In other words, they tend to one pole. The chlorine atom has a stronger attraction to the electrons because it has a greater electronegativity than the hydrogen atom. We can represent the hydrogen chloride molecule as H, delta positive, and Cl, delta negative. Thus, there will be an attraction between the delta negative on the chlorine atom of one molecule and the delta positive on the hydrogen atom of a neighboring molecule. The diagram below shows the permanent dipole-dipole force between the two molecules of hydrogen chloride, indicated here by the red dashed line. The second type of intermolecular force is the hydrogen bond. The permanent dipole in a covalent bond between the hydrogen atom and the fluorine, oxygen, or nitrogen atom is particularly strong. Thus, the attraction between the electron-deficient H delta positive of one molecule and the lone pair of electrons on a fluorine, oxygen, or nitrogen atom of another molecule is much stronger than the permanent dipole-dipole attraction mentioned before between the two hydrogen chloride molecules. This particular type of dipole-dipole attraction between the electron-deficient H delta positive of one molecule and the lone pair of electrons on a fluorine, oxygen, or nitrogen atom of another molecule is given the special name of hydrogen bond. So, a hydrogen bond is the attraction between the H delta positive of one molecule and the delta negative on the lone pair of a fluorine, oxygen, or nitrogen atom of a neighboring molecule. Even though a hydrogen bond has only about 5% the strength of a covalent bond, it does have a significant effect on the physical properties of compounds. For example, were it not for hydrogen bonds, both water and alcohol would be gases at room temperature and pressure. Number 3, van der Waals forces. Firstly, note the spelling of van der Waals forces. It is a lowercase v in van, and the apostrophe comes after the S in Waals. Van der Waals forces are induced dipole-dipole interactions. Let's look at how these arise. They arise out of movement of the electrons in the shells. If we could freeze the action at any moment in time, there would be an instantaneous dipole at that particular moment. These induced dipole-dipole interactions, called van der Waals forces, occur in all molecules, whether polar or not, but are the only intermolecular forces between non-polar molecules, such as the halogens and the noble gases. As the number of electrons in the molecule increases, so do the van der Waals forces. This explains why there is an increase in boiling point as we go down the group of halogens and down the group of noble gases. So, to recap, an intermolecular force is simply an attractive force between neighboring molecules. The three common intermolecular forces are 1. Permanent dipole-dipole forces, 2. Hydrogen bonds, and 3. Van der Waals forces. Hydrogen bonds exist between a hydrogen atom on one molecule.
Van der Waals forces. Van der Waals forces is basically the type of intermolecular forces, and it's present only between non-polar molecules, or non-polar molecules have Van der Waals forces. So Van der Waals forces, how does it arise? So we just watched it. How does Van der Waals forces arise?
Molecules move around, and then if we freeze it, either to একটা জায়গায় positive হবে, একটা জায়গায় negative, and the positive can induce and make the other molecular
Negative charge.
atomer ওই পাশেরটা এখানে
So,
আসলে negative.
let's take a chlorine molecule. A chlorine molecule. And a chlorine molecule is a diatomic molecule. And we know that electrons are spinning around. So at a certain instant, or they used a word, if we freeze it for a second, did you listen to that?
Yeah.
So
Yes,
for
yes, sir.
any particular instant, you'll see that there are more number of electrons on one side of the molecule compared to the other. There are more number of electrons on one side of the molecule compared to the other side. So the side which would have a greater amount of or greater number of electrons would be partially negative. And the one who would be deficient in electrons, or one whose distribution of electrons would be less, would be partially positive. So if we take another atom, another molecule. So the other molecule is a neutral molecule. Another molecule is a neutral molecule. It is a neutral molecule. Now, since its neighboring molecule has a partially negative charge, what will it do? It will repel the electrons. It will repel the electrons away. It will repel the electrons away. It is going to repel the electrons away. So as a result, what will happen? As a result,
Positive charge induced.
there's there's an induction of charge, or a charge has been induced. So since the electrons are repelled away, this side will become a partially positive, and this side would become partially negative. So now the attraction between this partially negative and partially positive gives rise to what?
Van der Waals forces.
Van der Waals forces. Clear?
স্যার
Yeah.
স্যার আরেকবার বলবেন যে ইলেকট্রনস কিভাবে মুভ করলো?
Electrons কিভাবে মুভ করলো? কোনটা? The orange one or the purple one?
The orange one.
So এখানে তো this is now partially negative, right? This is partially negative, তাই না? So this
Yes, sir.
partially negative charges will repel the electrons which were present. A molecular electrons গুলোকে repel করবে. So as a result, we saw it in the video that the electron charges were something like this. And then after repulsion, the electron charges became something like this. Right? Video te dekhayche na je there redistribution of charges.
Yes, sir.
So
check.
বুঝছো? So তখন কি হয়ে যাবে? So now this side has become partially positive, this side has become partially negative. So partially negative আর partially positive এর মধ্যে কি type of forces will arise?
Van der Waals.
Van der Waals forces. Van der Waals forces is the weakest type of intermolecular force. Weakest type of intermolecular force. Why? Because this is nothing permanent. এমন হতে পারে যে the molecule was something like this. We had electrons here. And suddenly all the electrons came to this side. or its distribution was like this. So this side is partially positive, this side is partially negative. This is on one instance. In the next moment, it could be that this side now has more number of electrons and this side has less number of electrons. So এখন এই side কি হয়ে গেল? What is happening? This becomes partially negative, this becomes partially positive.
Positive.
So this shows that nothing is constant. This is constantly changing. This is constantly changing. So that is the reason. This is a very that is the reason this is known as a temporary dipole forces. It's also known as temporary dipole forces, or it's also known as induced dipole forces, right? So the name has been derived from its properties. So why is it called induced? Because when one of the molecule which was previously neutral on both sides, suddenly when one of the molecule has more electrons on one side and less in the other side, it becomes partially negative and partially positive. This in turn induces a charge on its neighboring molecule. And when this keeps on going on, this keeps on going on, what happens? It's like a chain reaction. It's like a chain reaction. So এখানে number 1 থেকে number 2 হলো, number 2 থেকে number 3 হবে, number 3 থেকে number 4 হবে, তারপর 5 হবে, এরকম করে what happens? The whole group of molecules becomes charged and eventually gives rise to van der Waals forces. Now, if van der Waals forces are only, now it's not true, van der Waals forces are present everywhere, but specifically which type of molecules does van der Waals forces exist on, or which type of molecules only have van der Waals forces?
Diatomic.
No, non-polar molecules. So non-polar molecule just has one type of intermolecular force, and what's that?
Ionic.
Van der Waals
Sir,
forces. হ্যাঁ বলো।
so dipole কি?
Dipole মানে দুইটা চার্জ, এখানে একটা মলিকিউল,
Sir, polarity ওইভাবে?
হ্যাঁ একটা molecular ভিতরে on one side it has partially positive charge, on the other side it has partially negative charge, তাহলে কি হলো? Isn't it a dipole? There are two poles.
Yes, sir.
So that's why this is known as a dipole moment. So now, van der Waals forces. What are the factors affecting van der Waals forces?
Number of electrons and number of contacts.
Number of contact points.
Number of electrons and number of contact points. Great. কেন?
Sir, contact points টা বুঝি নাই।
Contact points না বুঝো, তোমাদের O levels থেকে আমি কিন্তু পড়ায় আসতেছি যে van der Waals forces increase when number of electrons increases, right?
Yes, sir.
Yes, sir.
এখন you would know why. শোনো, একটা ফ্লোরিন মলিকিউল, হ্যাঁ একটা ক্লোরিন মলিকিউল, একটা ব্রোমিন মলিকিউল, একটা আয়োডিন মলিকিউল। So fluorine molecule, what is the mass of a fluorine molecule? 38. What is the mass of chlorine?
71.
35.5.
71.
71
Sure.
দুইটা তো
71.
71.
91.
Bromine
160.
and iodine.
256
254.
Nana 54. 127. 254. 254.
254.
So what is the maximum difference in the number of electrons in case of fluorine? 1 and 37. And on one side you have 1 electron, on the other side you have 37 electrons. What is the maximum difference for chlorine?
1 and 70.
1 to 70.
1 and 70. Tale, if a fluorine molecule has 1 in this side, 37 on this side, 1 on this side, 37 on this side, and chlorine has 1 on this side and 70 on this side, 1 on this side, 70 on this side, car difference in charges beshi?
Fluorine.
Chlorine, exactly. So
70
there, because 71.
electrons.
Hey, electrons to 71 না স্যার?
সেটাই তো
তো
স্যার
তোমরাই তো আমাকে ভুল বললা তাহলে।
আপনি তো
আপনি তো math-ই বললেন।
আপনি math
বলি নাই।
Oh, sorry. Okay. No worries. I'm correcting it. So fluorine
18
18.
18
হবে, 18. Fluorine is 18.
34
34.
Chlorine would be 34. Yes, now it's right. Exactly. I was also being confused. 34. So bromine
70.
35, 70. 35 into 2. Or iodine
254. Oh. 106. 106.
53 into 206. Okay. So what is the maximum difference here? 1 and 33. What is the maximum difference here? 1 and 17. So anyways, you people understand the thing, right? So যত বেশি ইলেকট্রন থাকবে তত বেশি difference in charge থাকবে. So আমরা যদি if we take it as a size, তাহলে this would be like a small partial positive and a small partial negative. But this would be a small partial positive but a bigger partial negative. Now if we talk about bromine has 1 and 69. 1 and 69. So partially positive and a very big partially negative. So joto beshi difference in charges, the greater the difference in charges, the stronger the intermolecular force. So down the group, melting and boiling point increases or decreases? For group 7 increases. Why?
Van der Waals forces
Van der
forces increase.
Because Van der Waals forces increases. Why does Van der Waals forces increase?
Where difference
Number of
charge.
electron increases.
charge density
Because
electron density
because number of electrons increases. So O-level এর explanation কি তোমরা finally পেলা?
G sir.
Now are you clear? Now are you clear about this?
Yes.
Sir,
So দেখো,
contact point
আচ্ছা আবার একটু বলবেন প্লিজ, কতটা শুনতে পাইনি ঠিক করে।
non diatomic molecules মানে যারা simple molecular structure, just not that, যারা simple molecular structure, their melting and boiling point is low or high?
Low, sir.
Low. Why?
Weak intermolecular
Because
forces.
they're
Weak
weak intermolecular.
intermolecular forces. Okay, specifically if they're non-polar, they're weak Van der Waals forces.
Van der Waals.
Now for group 7, they're also simple molecular structure and they're also melting and boiling point is low. But as you go down the group, as you go from fluorine to chlorine to bromine to iodine to astatine, the melting and boiling point increases. Why does it increase?
Van der Waals forces increases.
Number of
Because Van
electrons.
der Waals forces increases. Why does Van der Waals forces increase?
Number of
Number of
electron
electrons
increases.
Number of
increase.
electrons.
Electronegativity
No, because number of electrons increases. তোমার কি ইন্টারনেটে প্রবলেম? আমাকে can you hear me clearly?
Yes, sir.
না না ইসফার.
হ্যাঁ স্যার এখন শোনা যাচ্ছে, এটা মাঝে মাঝে একটু ডিস্টার্ব করে।
Are you using data or Wi-Fi?
না ডেটা।
Oh, that's why. It's a problem. Why try to take a Wi-Fi because data is একদমই not dependable. Anyways, so আপাতত এটা. Next is Van der Waals forces also depends on Van der Waals forces depend on number 1, number of electrons, and number 2,
Contact.
number of
Contact points.
চলে যাই আমরা অর্গানিকে। অর্গানিক তাসনিম বিনতে তৌফিক।
Yes sir.
বিউটেনের নাম্বার অফ কার্বন অ্যাটমস কয়টা?
2.
Butane has 2 carbons.
Sir, 4.
4. Sorry.
And how many hydrogens?
10.
Okay, good. 10. মুজাম্মেল, বিউটেনের একটা আইসোমার বলো তো, আইসোমার। বিউটেনের একটা আইসোমার বলো।
স্যার বলি স্যার H তো নড়াইলে তো হয়।
H নড়ালে হয়?
আরে না, ওটা ইয়ার জন্য।
হ্যাঁ,
কি বলে
বলো ফারান।
বিউটিনের জন্য।
স্যার 2 methyl propane।
2 methyl propane. 2 methyl propane. So 2 methyl propane would be something like this.
স্যার এটা কি আইসোমার?
কি আইসোমার বলতে?
স্ট্রাকচারাল না পজিশনাল? স্ট্রাকচারাল না?
স্ট্রাকচারাল।
না, সবই তো স্ট্রাকচারাল। This is chain isomerism, chain.
আচ্ছা। স্যার এএসএ কি জিওমেট্রিক্যালটা পড়তে হবে?
জি স্যার।
স্যার এগুলা কি?
এগুলা কি মানে?
একটু কমানো যায় না সিলেবাস?
হ্যাঁ, আমি তো সিলেবাস বানাচ্ছি না। যাক বলো। সো এখানে কন্টাক্ট পয়েন্টস, দিস আর কন্টাক্ট পয়েন্টস। আর এখানে কন্টাক্ট পয়েন্টস দেখো। So দেখো, these are more regularly arranged. এটা একটা কার্বন চেইন, এটা একটা কার্বন চেইন। There are more attractions. But এখানে কার্বন চেইন কি হচ্ছে? It's like a T-shaped carbon chain, right? So interactions are less between the chain. তাহলে তোমরা বলো contact points বেশি কার?
Butane.
So who's going to have a higher or stronger Van der Waals force?
Butane.
So first of all, we studied that Van der Waals forces depends on the number of electrons. And number 2, if the number of electrons is the same, এখানে দেখো butane is C4H10 and 2-methyl propane is also C4H10. So both of the compounds has the same number of electrons. Then what will their why would their melting and boiling point differ?
Number of contact points.
Number of contact points. So একটা জিনিস মনে রাখলেই হবে, straight chain organic compounds. So এটা কিন্তু শুধুমাত্র organic compounds এর জন্য। Straight chain organic compounds have more contact points? Have more
এগুলা কি লিখবো?
দরকার নেই, বুঝো আগে বুঝো। Straight chain organic compounds have more contact points, therefore their van der Waals forces are stronger, therefore high melting and boiling point. Our branch chain organic compounds have less contact points, therefore they will have a lower melting and boiling point. Clear?
Sir, does this apply for all organic compounds?
Yes, yes. Acha, AKS. AKS.
Yes.
তোমাদের স্কুল ক্লাস কয়টা পর্যন্ত?
2:20
স্যার 2:20
আসলে
ঠিক আছে, আমরা হয়তোবা একটু 10 মিনিট পরে স্টার্ট, মানে আই থিংক 3 ইজ ওকে নাকি?
জি স্যার ঠিক আছে স্যার, সমস্যা নেই।
সারাদিন ক্লাস করব, টায়ার্ড হয়ে যাব না?
ইয়ার করার দোস্ত, দিস ইজ এএস লাইফ।
আচ্ছা,
বেশি বেশি
তো তোমাদের প্রতিদিন তো আমার সাথে ক্লাস করতে হয় না?
না, ওটা ছাড়াও তো অন্য ক্লাসেস আছে।
হ্যাঁ, তুমি 4টা সাবজেক্ট নিতে
স্যার
হবে। হ্যাঁ
স্যার 3:30 পসিবল না, তাই না?
3:30 পসিবল, কিন্তু কিছু ডিপিএস এর অনেকে তানভীর স্যার থাকে।
পসিবল না স্যার।
তানভীর স্যার থাকে, এটা প্রবলেম।
আচ্ছা স্যার,
আচ্ছা, so we'll start from 3:10, so 3 will be official timing, so ধরো যে we'll start from 3:10। এমনি তো আমরা 3:10 স্টার্ট করি।
হ্যাঁ হ্যাঁ,
আচ্ছা স্যার, সমস্যা নেই, বাসায় তো আছি।
হ্যাঁ, বাসায় আছে, so you don't need to go anywhere, so
সেটাই। ঠিক আছে,
so তোমরা তো কিছুদিন পরে ল্যাপটপ ছুঁড়ে মারবা বাই ইওর পিসি। এত সারাদিন মনিটরের দিকে তাকায় থাকতে তো চোখ ব্যথা হয়ে যাবে।
স্যার এখনই তো কষ্ট হয় না, এখনো তো কষ্ট হচ্ছে, সব কোচিং তো অনলাইন।
তোমরা একটা কাজ করো, তোমরা কানেক্ট ইওর ল্যাপটপ টু ইওর টিভি, তাহলে
এটা তো আরেকটা প্রবলেম।
কেন?
আবার কানেক্ট করো,
HDMI কর্ড কিনতে হবে, HDMI কর্ডের
আমি তো
কিনতে গেলে বাইরে যেতে হবে।
এইজন্য দেখো আমি কিন্তু অ্যাঙ্গেলে তাকাই থাকি, বিকজ আই হ্যাভ আ মনিটর which is very far away, যাতে আমার চোখ ব্যথা না করে। I wear this specs because so that UV lights, আমার ডাক্তার বলছে যে only when you use your laptop you use the specs।
আমার ওটা একটা ছিল, বাট ভেঙে গেছে চশমা, এখন কি করব বলেন?
ওরা লাগা বড় প্যারা কি?
আল্লাহ, আমার মা বাইরে হতে দেয় না ঠিক মতো, আবার গিয়ে বসে চশমা আবার কিনবো একটা।
হ্যাঁ, ট্রু। স্কচ টেপ দিয়ে বানায় নাও একটা লেন্স।
আরে মানে ওইটার ইটাই ভেঙে গেছে, গ্লাসটা।
ও আচ্ছা আচ্ছা আচ্ছা, ওকে।
এখন আমি এমনি একটা চশমা পরি, এটাও ভাঙা, ফ্রেম ভাঙা।
That's sad.
স্যার I also think I will need a spectacle soon, যেভাবে অবস্থা।
আমার পাওয়ার বেড়ে গেছে।
স্যার জানেন, কোয়ারেন্টাইনের শুরুর দিক দিয়ে না আমারও ওই যে আগে চশমার ফ্রেমটা ভেঙে গেছিল, তারপর আমি হট গ্লু দিয়ে করে রাখছিলাম। It worked.
It worked. Good.
Yeah.
But Nikita has a different problem. She broke her lens, so
এটা একটু
হট গ্লু করে ফেলো।
করব। স্যার আমি আর চশমা ছাড়া টিভি দেখতে পারি না।
that's sad.
সব খোলা দেখি।
So এখন কি তোমরা লিখবা Van der Waals forces এর
না
explanation?
না না।
আচ্ছা, I think লেখার দরকার নাই। I think লেখার দরকার নাই because I'm going to share it. লিখলে পুরো আজকের ক্লাস এই লিখতে লিখতে তোমাদের সময় চলে যাবে।
Thank you sir, you are a gem.
But have you understood how these Van der Waals forces arise and what are the factors the Van der Waals forces depends on?
Yeah.
So if you send us the notes, we have to copy all of it and then send it back to you. Right?
Yep.
Sir, will you upload the notes in Google Classroom?
Yep.
মানে intermolecular forces আর কি।
Yep. Yep.
তারপর লিখে কি দেখাতে হবে যে লিখছি?
Can I just print it out?
লিখলে মনে থাকবে, সো ইটস ওকে।
শুনো,
The plus
কে বললো যে can I print it out?
Sir, me.
সবাই, everybody doesn't have a printer at home. Did you submit your notes last class?
No, sir, but I did them.
So you have to take pictures of your notes after each class and upload it to Google Classroom. You have been marked 0 last class.
Oh, okay.
Okay, so van der Waals forces is number of contact points. So this is pentane, this is 2,2 dimethyl propane. So you can see when a molecule is branched, it has less number of contact points, therefore the melting and boiling point is lower. So although pentane and 2,2 dimethyl propane, both of them have the same number of carbon atoms, same number of hydrogen atoms, but still pentane has a boiling point of 36 degrees centigrade and 2,2 dimethyl propane has a boiling point of 10 degrees centigrade.
স্যার আপনার কথা বেশি ভালোভাবে শোনা যাচ্ছে না।
অনেক বেশি তাড়াতাড়ি বলে ফেলছি তাহলে। So pentane and 2,2 dimethyl propane, they both have the same number of carbon and hydrogen atoms. But since pentane is a straight chain hydrocarbon, therefore they have more number of contact points. Therefore, they have stronger van der Waals forces. Therefore, they have a higher melting and boiling point. And 2,2 dimethyl propane, their number of contact points is less. Why? Because they're branch chain hydrocarbons. Therefore, since they're branch chain hydrocarbons, they have low number of contact points, their melting and boiling point is lower. Okay,